Conversations with Apollo, episode number 2, Honeysuckle, part 1.
In the whole history of man, this has to be the proudest day of our lives. Because of what you have done, the heavens have become a part of man's world.
My next guest on Conversations with Apollo is Mike Dinn, former director of the Canberra Deep Space Tracking Station in Australia. Mike worked on the Apollo project and the Honeysuckle Creek Tracking Station from 1967 to 1981. Mike, thanks for joining us.
Oh, you're welcome. It's good to speak to you.
Great. Well, why don't you tell us a little bit about how you actually ended up at Honeysuckle and how Honeysuckle came to be?
Well, Honeysuckle Creek Tracking Station, which is about 20 miles from where I am now in Canberra, Australia, was one of the space tracking communication stations specifically put in for the Apollo program. There was a network called the Manned Spaceflight Network, which was implemented by Goddard Space Flight Center in Maryland, and when it came to missions, we responded operationally to Houston. And so there were about 130, 140 of us at the peak time during the peak years of Apollo, provided the communications in this area. And it was one of 3 special stations in the MSFN, Manned Spaceflight Network. There was ourselves, a station near Madrid, and one in Goldstone, which is near Barstow in the Mojave Desert. We were the ones designated to provide the communications at lunar distance, at the moon's distance. And so we had a much larger antenna dish than the other MSFN stations.
If I'm correct, the TV signal largely came through Honeysuckle, didn't it? All the TV images?
Well, that's right. As it happened to work out on Apollo 11, although all the stations were equally competent, then we at the Honeysuckle Creek Station, just by sheer luck, happened to be the ones in view at the time of the first step on the moon. I might say Goldstone was also in view at the same time, but because of various technical and operational reasons, the signal that was actually selected at Houston when it went out to the world was the one that had originated at the Honeysuckle Creek Tracking Station.
I have vivid memories of that first grainy black, being 8 years old, sitting in front of my dad's black and white television set, and seeing those first grainy images from the moon and having them be upside down. What was that all about?
That's quite true, and you'll hear that comment by the Capcom just after the television comes on. If you watch that little bit of the video there, his first comment is something like, I have a great deal of contrast, but it's upside down on my monitor. And there's quite an interesting story behind that. The camera itself was mounted on the base part of the lunar module, the so-called MESA, something like Main Equipment something.
Storage area or
the
something.
acronym stands for now. And when Armstrong came out on the porch of the top of the ladder, he pulled a lanyard which allowed the platform on which the camera was mounted to swing down. But the geometry was such that the camera was upside down. Actually, not quite, but almost upside down. And so at the tracking stations, we had a special switch, quite a physically big one, on what we called the scan converter. That was the TV equipment which converted the grainy black and white into a grainy black and white to the American standard, NTSC. And the first picture they were taken from Goldstone, that switch was in the wrong position. And therefore the picture that went to Houston was upside down, and the one that went out for a little while. We have on our Honeysuckle website the actual conversation that went off between Houston and Goldstone and ourselves at Honeysuckle during that period. And you hear Mr. Houston TV call up Goldstone and say, would you put the switch in the other position? So, yes, the picture was upside down initially. Also, its contrast was poor, or rather, it was very black and very white. There wasn't a shade of greys. And after a minute or two of using Goldstone's picture, the Houston TV controller decided the Honeysuckle one was better and switched to that. And again, you'll see that happen if you know what you're looking for on the TV just as it's coming down the ladder.
So you actually started with, I believe your period of time actually started with Surveyor. Am I correct?
Well, that's so. I was at the what you might call the sister station. That was the Deep Space Station, about 10 miles away from the manned flight one. And I arrived here in 1966, and the very first mission I was associated with was Surveyor 1, which was the first soft landing on the moon. And that, in many ways, was as exciting as Apollo. There had been the Ranger missions prior to this, where spacecraft had crashed into the moon, taking pictures on their way in. But Surveyor 1, which was built by Hughes Aircraft at El Segundo in Los Angeles, no one expected that to successfully, well, even get out towards the moon. It was on the Atlas Centaur rocket, and there had not been one successful flight of the Atlas Centaur up till that point. But much to everybody's amazement, the rocket worked perfectly, the spacecraft worked perfectly, and it landed perfectly. And we had the fascination of tracking that mission, and then after it landed, we tracked it right through the first solar day. It survived the first lunar night, which no one expected it to, and came up again the next day. So Surveyor was where I sort of cut my teeth on space tracking, which was of great value when it came to Apollo, because I don't know how many people realize this, but the communication system that Apollo used was more or less the JPL designed communication system which was being used in the Deep Space Network.
And then from Surveyor, that you transferred over to Honeysuckle Creek in '67, just before Apollo 7. Am I correct?
That's right. Actually, I was at Apollo. It was about a year before Apollo 7. We did support 2 or 3 of the Saturn V, AS501, AS502 missions. Some didn't even come into view with us, but the very first mission I was directly responsible for was Apollo 7. That was the first time we'd actually done routine tracking, and it was the first time that the S-band system had been used regularly in Earth orbit. All the Gemini missions used UHF, and that was relatively forgiving as far as pointing with an antenna, but you went up from 400 megahertz up to 2.2 gigahertz when we changed from Gemini to Apollo. So, and when you've got a relatively large antenna like the one we had at Honeysuckle, it had a beam width of about a third of a degree. So one had to point with a great deal of accuracy, and it took a little while for the whole system, communication system, Houston, the generation of the pointing angles and the accuracy of the antenna to work. So Apollo 7 was quite a challenge for us, but we got through it quite well. And it was only towards the end of Apollo 7 that little mutters started coming out saying, hey, could you support a lunar mission before the end of the year? I think Apollo 7 was about September 68. And then by December 68, we had Apollo 8. And a lot of us look on that as, in many ways, well, certainly from a communications point of view, as important as Apollo 11 in many ways.
Yeah, I mean, if you think about the differences between Lindbergh crossing the Atlantic and and Columbus going the other way and everything. I mean, I agree with you that even though Apollo 11 is the epic step and landing on the moon and all, that couldn't have happened unless Apollo 8 had been successful.
Well, that's right. And the confidence with which the whole program and project took on, sending 3 men out to out of Earth orbit, out of the Earth's gravity, and going behind the moon and being literally out of communication, burning their rockets. There's SPS rocket behind the moon to go into orbit. Was really quite incredible. I mean, when I look back on it, we really were full of, we being the whole, everybody was associated, hundreds of thousands of people, we were amazingly confident in our competence. But the beauty was that everyone knew what they were doing, everyone knew why they were doing it. There were no real significant budget constraints or resource constraints. There was a lot of redundancy built into the spacecraft, into the rocket, and into the ground system. And the engineers were allowed to do the engineering and get on with the job. And I don't know if that will ever happen again, but if they're serious about getting ever a trip to Mars, there will have to be some policy that allows the people who are the ones who have to actually do things to get on to doing it, and the administrators and bean counters stand in the background somehow.
It's kind of like so many things. It's amazing how many things you can do when you don't realize you're doing them, and then when you realize you're doing them, all of a sudden things are impossible.
Yeah. And we were doing, then from Apollo 8 onwards, we had missions at 2-month intervals. We had Apollo 8 at about Christmas '68, Apollo 9 where the lunar module was checked out in Earth orbit, and that was quite a challenging job from a communications point of view, because communicating with the lunar module was never designed to work in Earth orbit. So we had quite a few things to work up for Apollo 9. And then there was Apollo 10 with John Young, which replicated the whole mission apart from the landing. And we were having I remember the documentation for the next mission was coming into the station before we'd flown the previous one. And then 2 months after Apollo 10 was Apollo 11. As I say, at the time, I don't know, it didn't seem that big a deal, but looking back on it, for that period, 7, 8, 9, 10, and 11 was really an incredible period.
Yeah, when I think of that, when Apollo 8 took off, they hadn't even written the software for Apollo 11, which was to land 7 months later. It's truly amazing the amount of work that they got done from the time Apollo 8 came back to the time Apollo 11 actually landed on the moon.
It sure is, and also when you look back at the technology we were using. I mean, for example, I'm sitting in front of my computer here, which has a broadband 1.5 megabyte communication anywhere in the world. We ran the whole of the Apollo mission on 2.4 kilobit lines out of the station and back to Houston.
Let's repeat that. Let's repeat that. 2.4 kilobit.
2.4 kilobits.
Wow.
2,400 bits per second.
That's amazing.
More as a hundredth of what people are using in a home environment these days. Some people. And then on top of that, so what it meant was that the telemetry had to be manipulated, selected, sampled, and squeezed to go down one line. And the astronauts' biomedical data, heart rates and EKGs and the like, went down the other line. We successfully ran the mission with those 2 lines, plus voice lines. We had 3 more lines coming into the station. We had one that carried the Capcom's voice, which went up to the spacecraft. We had a circuit where we coordinated our operations with Houston. And we generally had a 3rd circuit where we coordinated the engineering and support aspects with the Goddard Space Flight Center.
That's a lot of balls in the air for for the amount of computing power that they had back then.
Well, that's right. But one interesting observation I make of that era is that most of the equipment was analog in varying forms and manners. This meant that you had to have quite a few operators. Each piece of equipment generally had to be operated by a person. And there were knobs to twiddle and adjustments to be made and tuning that could be done. And we had systems which really relied on people to get the most out of, and also to respond to anything out of the ordinary. For example, when we supported Apollo 13, there was a great deal of writing of the book had to take place on the fly there. But because the equipment was analog, because it was flexible, because we had skilled and trained operators, we coped. But in this day and age, you're dependent on the man who writes, or the person who writes the software for the computers, and providing they've thought of everything that can happen and have written down and explained what to do under all circumstances, you'll get by. But if they haven't thought of a particular configuration or situation, all that the operator can do is just throw his hands in the air.
Yeah, I kind of remember.
In other words, but you're doing the task. You've got one person, one or two people, whereas we had 50 or 60 doing the same sort of thing, but in a much more flexible way.
Now, I'm reading here that you guys had to sort out the lunar module signal on Apollo 13 from the S4B signal that was on the same frequency?
Yeah, that was a big challenge. What happened was that the lunar module and the Saturn 4B transmitted on the same frequency, the same S-band frequency. And, of course, it wouldn't normally be a problem because the lunar module was not intended to be turned on or fired up from a communications point of view until it was in lunar orbit.
And it certainly wasn't going to be coming back.
Pardon?
It certainly wasn't going to be coming back.
Yeah, well, that's true, but what they did on Apollo 13, they fitted extra batteries onto the S4B to keep it transmitting until it impacted the moon. And the reason they did that was to provide an impact that could be picked up, hopefully by the seismometers left by Apollo 11 and Apollo 12. And so we had the Saturn 4B radiating on, I can't remember the exact number now, and then when they went into the lunar module from the lifeboat point of view, lo and behold, when they turned the lunar module on, there it was, same frequency, mixed up with the Saturn 4B. And we were the ones primarily tracking at the time that occurred. And I had quite a few conversations with Houston and Goddard as to how we could make this work. We did eventually, but we also had the Parkes radio telescope dish. We got people up to there within 2 or 3 hours of the explosion on Apollo 13, because with a big dish like Parkes, which is a 210-foot diameter, it has a much narrower beam width, and therefore the S4B and the lunar module weren't on exactly the same trajectory, and the hope was that we could help separate the signals out that way. But Apollo 13, in many ways, I say that for a nominal Apollo mission, we used about 10% of our capability. For Apollo 13, we use about 95% of our capability.
It truly makes it even more miraculous that they made it back. I mean, it's just such an amazing story.
Very true. But the beauty of the whole Apollo program was there were so many people, so dedicated, and not only allowed to get on with the job, but expected to get on with the job. And the way it ran was, I did my job, and I didn't attempt to do anybody else's. There was no marking of other people's homework. You all did your job. You assumed that the other person was doing his job, and you didn't have time anyway to worry about what others were doing. Whereas I'm afraid in the modern era, there's an awful lot of people spend a lot of time doing other people's jobs.
So now Honeysuckle still operates, am I correct?
Well, not yes and no. The actual site where the antenna was has been demolished now, but in 1983, the 26-meter or 85-foot diameter antenna, which was an XY mount, was dismantled and then rebuilt at what is called the Canberra Deep Space Communication Complex, which is the Deep Space Network tracking station near here. And so the antenna from our Honeysuckle days is in daily use today in tracking at the CDSCC. And if anybody's interested, they can just Google CDSCC, and you'll find the complex where it is. There is talk about turning the antenna down in a year or two, I've heard, but and we've sort of started a sort of little movement to try and make sure it doesn't get scrapped.
I was going to say, you guys need to have a National Historical Monument movement.
Well, it could and should be so done. They've done something similar at Goldstone, I understand, with some of the older antennas there. Whereas in general in Australia, I'm afraid they've tended, when an antenna's been finished with, unless they could find a radio astronomy use, they've tended to be pulled down for scrap.
Mm. Wow. But the whole system, though, over at Honeysuckle, though, it has quite a pedigree, though. I mean, I'm reading here that you pulled a lot of the equipment out of the coastal century Quebec from the Gemini days. To build around it?
I went over to Perth, Western Australia, when the CSQ came into Fremantle there, and I selected various consoles and items. The reason we did this was I had decided, and my boss Tom Reed concurred, that we should try and build ourselves a simulation system. On one of my visits to Houston must have been about 1968, I had the joy of sitting in some of their simulations where they were simulating launches, and they'd take the clock from launch -3 up through a simulated launch with a contingency, have a quick debrief, and then repeat it. And they're doing hour after hour of these simulations of contingencies, and I realized that we didn't have that same depth of expertise. And so I decided it would be a good, challenging engineering job anyway, and a worthwhile and a good training device to build a simulation system. So we got these consoles, meters, etc., and bits and pieces out of the CSQ, and some very smart technicians and engineers at Honeysuckle built us up a really good simulation system, and we could make it look just like the real mission. The only major problem we had was that we didn't have an American accents to simulate an astronaut getting out on the moon. So we had Australians pretending to step on the lunar surface, which wasn't very realistic. So that was a unique thing we did at Honeysuckle, and it was well worthwhile.
Well, that was a very heady time. I guess my father, if he were alive today, he would probably have a few words to say to you guys, considering that during the Apollo 13 mission, I was up for 4 days straight at 10 years old. I wouldn't go to bed, and I was just sitting there watching every little thing.
I had a culmination of my experience on Apollo. It was Apollo 17. I sort of left Honeysuckle and went back to the Deep Space Station during 14, 15, 16, and then in 1972 I had a year based in Los Angeles at Pasadena at the headquarters at JPL. But during the building of the big new 64-meter antenna, my job was to coordinate the Australian end of it, based at JPL. And I recognized that it was going to be finished just in time to support Apollo 17. So I proposed, and my boss concurred, and Goddard and Houston agreed, that we should try and use the big new dish at Tidbinbilla for Apollo 17. This gave me an excuse to visit Goddard a couple of times, but the best of all, it gave me an excuse to go to Houston for Apollo 17. So I was there for the launch of Apollo 17, and I got to sit in the MOCA with the network people, and with INCO, Ed Findell, who I'd known over the years. Ed was in charge. It was the flight controller in charge of all the communications, and he'd been out to Canberra, and I'd met him a couple of times, and so I sat on his console with him during parts of Apollo 17. And at one stage he says, "Hey Mike, I'm just going out for 10 minutes. Keep sending these omni-swap commands." These are the commands that where the spacecraft is doing a rolling motion on its way out to the moon, barbecue it used to be called. And so
passive thermal control.
Commands to swap the antennas. So I had the joy of sending commands for Apollo 17, and that was almost the highlight of my career, just not far behind the first step on the moon.
Oh wow, that must have been like being a kid in a candy store or going to Disneyland for the first time.
It was. It was. Ed was quite a character, and I remember Gene Kranz was the flight director at the time, and the Inco console was about 2 along to the left from flight director. And I remember Gene looking over, thinking, that sort of, obviously looking, who the hell's this person sending commands to his spacecraft. I had met Gene Kranz earlier, though. We got to know most of the players and the controllers and network people who interface with us.
Yeah, Gene Kranz is the stereotypical hard-charging Marine in my book. I mean, if you looked up Marine in the dictionary, you would see Gene Kranz's face. I mean, he was just that type of guy. Yeah.
He was, of course, when it comes to these various documentaries and movies on the Apollo missions, most of the TV and film comes from that MOCA, as it's called. But it was sort of literally the tip of the iceberg. That each controller there had his own back room of 10 or a dozen people. And each of those had their own industry specialists. I mean, for example, the network controller was 2 along to the right from the flight director. And we got to know those people quite well. But down in the bowels of the building 30 there was a man looking after telemetry, and another looking after command, another looking after tracking, another looking after voice, another looking after television. And they, in turn, had the whole of the network responding to them. And so it's always quite misleading the way that the inference is that all the decisions is sort of made in that room. They're not. Obviously, important decisions are made there, but it was a beautiful hierarchical organization where everybody had their place, knew what they were doing, and did it.
And then you stayed with the program all the way up until 1994 when you retired.
I did. I did have 10 years out of the system from 73 to 83 when I worked with our Department of Defense on aircraft projects. But in 83, the opportunity came up to go back to where I started at the Deep Space Tracking Station as the Deputy Director. And so that was marvelous. After working in the Canberra, which is like the Washington bureaucracy, I had the joy of going back to the hands-on engineering world. It was very amusing, really. After 10 years in the central office bureaucracy, when I got back to the station, and when someone could come up with a suggestion for doing something, my first reaction, which had been drilled into me for 10 years, was, why should we? Whereas after 3 months, I finally realized that my reaction should be, why shouldn't we do something? And I got back into the swing of real-time operations, and we had the joy of handling the Voyager flybys. Were mostly supported out of Tidbinbilla because the Voyager was in the southern, high in the southern skies. So the Uranus and Neptune encounters were all done while we were in view. And on the Uranus encounter, I ended up talking to Vice President Dan Quayle, who was visiting JPL at the time, and he wanted to know what we'd been doing here in Australia. We were, I might say, supporting shuttle missions as well for a while, until they got the relay, the TDRSSs, the Tracking Data Relay Satellites in place, and by which time they did not need all the ground stations. They just had this one facility at White Sands, which I think is still the case, although I'm not in touch as I was. So in 1994, actually it was the 25th anniversary of Apollo 11, I'd arranged to get John Young to come out here for our 25th anniversary, and also working with the NASA representative here in Australia, we got John Young to bring out a piece of an Apollo 11 moon rock for permanent display at our visitor center at the station here. So John Young turned up, and we had a fantastic party. There were about 300 or 400 old-time people. The moon rock is still on display, and I decided to retire on the 25th anniversary of Apollo 11.
Well, that's a pretty good way to go out.
Yes, it was. It worked out. It worked out very well for all concerned. So then, and I have pictures on my wall here in the office I'm sitting in right now of John Young presenting me a going away present. I also got a picture here of when Alan Shepard visited the Honeysuckle station. He was a very interesting character. He came along with Eberhard Rees, who was Werner von Braun's deputy, and in fact went on to succeed von Braun at Huntsville. And again, if people are interested, if they Google Honeysuckle Creek, they'll find a website which a space not in Sydney here, and I mean that in the nicest sense, Cole McKellar has put together in the last few years. And all these photographs, all the audio, all the television are all on that website. And it really is a fantastic site, not only for Honeysuckle, but he's doing it for the deep space side. And we had a very busy tracking station on the west coast of Australia called Carnarvon, which was a prime station for Gemini and a prime station for Apollo. It did all the near-Earth tracking and the tracking of the lunar packages that the astronauts left. So just Google Honeysuckle Creek as one word and you'll find the website.
Yeah, the website, I'm looking at it right now, is www.honeysucklecreek.net. And it's celebrating
Correct.
the 40th anniversary of the tracking station I see here. So. We
did. A couple of years ago we had... and also we've had I arranged a party for the 20th. I arranged a party for the 25th. I went to Parkes for the 30th in 1999. The 35th we had a big party here in Canberra, and the 40th when was that?
March, I believe.
Is to come.
Yeah.
To come.
Oh, is it? It's coming.
Yeah. That's right. So it's probably the last one that people like us, who are now in our 70s, I mean, we were in our 30s when all this was happening. And for anybody who's listening who might like to make a career out of space, it's a very, very rewarding, fascinating world to be in. It's very satisfying technically, and there's great, and hope, even today, there's great scope for initiative and bright ideas.
So, looking back over your Apollo experience, is there one or two things outside of the sending the commands from Apollo 17? There's one or two things that really stand out in your mind that maybe none of us have ever heard before that you can think of? Well,
not long before they were going to step on the moon, we were having problems with their EKGs and the backpack, the suit pack telemetry. And that I was on the console at the time, and I was quite worried about it. It's ironic that the television of the first step on the moon is the one that most people ever remember. But in practice, that was quite secondary to to things like the telemetry from the astronauts and the backpacks. I mean, they were literally involved in the survival, and so my worry at the time wasn't about television at all. It was about all that life-saving stuff, and so that's a bit of a negative memory. And the other one was Apollo 13, when I was just getting ready to start tracking, and I just heard in the background, Houston, we've got a problem. And my ears pricked up at that. We were just acquiring on our eastern horizon as that happened. And right at the very end of that mission, we were the last station to track it on its re-entry and prior to splashdown. And it got faster and faster, of course, as it screamed over Australia and disappeared over the eastern horizon. And then we never heard another thing. No one bothered telling us on the network what had happened and whether they'd landed or not. And so my boss, Tom Reed, rang up his wife and said, well, we don't know what happened, but we finished tracking, we'll be home soon. She said, I'm watching them on the parachutes right now.
So you found out. So you found out they made it from your wife.
Yeah, who was watching television. No one thought to tell us at the station, but that didn't matter.
So looking back, imagine someone listening to this recording, say 5-10 years from now, when we're actually going back to the moon. What would you have to say to some bright young guy that's working for NASA, who's frustrated with the progress that's going on, or who's trying to do his best to keep the signal going? What would you say to them as a voice from the past?
You have to be single-minded. You have to be focused. You have to be dedicated. You have to not let frustrations get in the way. There will be frustrations. We have frustrations, but providing you recognize that any job has frustrations, you'll put up with them, and the rewards will be unbelievable. That people will look back in 5, 10, 20, 30, 50 years and won't necessarily say this is their finest hour. I might say that we didn't make such a big deal out of the Apollo program because we really thought that was the first of a mass of other programs to come along. But of course, it hasn't evolved that way. The challenges of a Mars landing will be enormous, but probably no more enormous than we coped with on Apollo and the Moon.
Well, as a voice from experience, and one last question, and I'll let you go. As a voice from experience, what do you think of the new setup, the new program to the Moon, to Mars, and beyond? What are your feelings of the design, the plan that's presently in place based upon your understanding? How do you feel about it?
Well, firstly, I'm not close to it, but I'm sure if the engineers are allowed to design and work the program, there will be no problems whatsoever in achieving lunar landings and lunar explorations and bases. My worry is that the political, bureaucratic, administrative infrastructure, which has to exist, but has to keep out of the way, has to set all the parameters, set the political objectives, but let the people who are competent in the engineering do the engineering. And that is my concern. It's not that the technology doesn't exist. The technology has been around for 30, 40 years in its various guises. And I think things are going down the path, but until unless there's a dedicated president and Congress supporting these missions, and or there's some sort of political imperative, which I can't imagine where it'll come from, but there does need to be some political focus on what's being done. And I'd like to think that the U.S. could see that if it's interested, as it should be, in its world image, that demonstrations of achievements in any area of technologies, and in particular space, is well worth pursuing and can cost a fraction of what's being spent in other areas right now. So I'm optimistic that something will happen, that the mission will occur. I think the technology is pretty straightforward. I think ground communications will be as important as they are today. I can't see it being substituted for a long while to come.
Well, here's hoping that when we do go back to the moon or even step on Mars, that you'll be a guest of honor in the mission control room to send a few more commands their way.
I hope so. I was very lucky in being in the right place at the right time. Thoroughly enjoyed it.
Well, thank you very much for joining us. My guest has been Mike Dinn, former director of the Honeysuckle Creek Tracking Station, which played a great and pivotal role in the coverage of the Apollo program. You can find out more information about the Honeysuckle Creek Tracking Station at www.honeysucklecreek.net. You've been listening to Conversations with Apollo, a weekly podcast for space history fans everywhere. For more information, visit our MySpace page at www.myspace.com/conversationswithapollo. Or you can leave us feedback on our iTunes website. And if you know anyone who worked on the Apollo program who has a story to tell, we want to hear it. Just have them drop us a line at apollotalks@gmail.com. Theme music is from Gemini 5, courtesy of the PodSafe Music Network. The song is Babylon Rockets. Visit them on the web at www.gemini5.com. Conversations with Apollo is a copyrighted podcast under the Creative Commons license from Quindar Entertainment. Copyright 2007.